We say that corresponding parts of congruent triangles are congruent, and it has a commonly used acronym CPCTC. It's a restatement of this definition for congruent triangles. And the acronym is used quite often as a reason in proofs. For the purpose of review, here's a picture of two congruent triangles with 6 statements of congruence for the 6 pairs of corresponding parts. And at the bottom is one more statement of congruence that states that triangle ABC is congruent to triangle XYZ. Here's a definition you might already be aware of. A circle is the set of all points in a plane the same distance from a given point. We haven't exactly defined plane, but for now we'll just remind everyone that a plane is a flat surface. We'll get into planes more in later lessons. Here's our given point A, and the orange circle around A is the set of all points the same distance from that given point. We use that symbol, the little circle with the dot in the middle, to stand for circle, and we label this circle Circle A. And now I've placed and labeled 3 points around the circle, points L, S, and C, and they are points on the circle. And if we connect those points to the center, we have 3 radii. A radius is a segment with one endpoint on a circle and the other endpoint at the center of the circle. AL, AS, and AC are all radii of this circle. Then we have another definition, chord. A segment that has both endpoints on the same circle is a chord. So CL, BS, and LS are all chords of circle A. And then one more word you may already know the meaning of is diameter, and that's a special type of chord. So for the 3 chords in the previous frame, one of them, BS, is a diameter because it's a chord that passes through the center of a circle. You may already know that the ratio of the circumference to the diameter of all circles is the same, and of course that ratio is called pi. Pi is an irrational number. That means that it is an infinite non-repeating decimal. A common approximation for pi is 3.14. March 14th is often celebrated as Pi Day. The next 2 digits of pi are 1 and 5, so we get 3.1415. So in 2015, Pi Day will be extra special, 3/14/15. And because if you round to the nearest 10,000th, you get 3.1416, perhaps Pi Day will be extra special in 2016 as well. And you may already know the formula to find the circumference of a circle. If you multiply pi times the length of the diameter, you get the circumference. So the circumference is equal to pi times d, where d stands for the length of the diameter. And since you may have figured out that the length of 2 radii is equal to the length of a diameter, we could also write that formula as the circumference is equal to 2 pi r, where r stands for the length of a radius. Another important formula you may already be aware of is pi r squared, and that's the formula to find the area of a circle. And that brings us to Theorem 19. All radii of a circle are congruent. And in order to prove that theorem, we need an important postulate. 2 points determine a line, and they also determine a ray or a segment. This postulate is very important, and many geometry textbooks introduce this postulate as one of the very first things in the course. Well, now we're going to write a paragraph proof for Theorem 19. The definition of a circle states that all points on a circle are the same distance from a given point, which is the center. Each of the given points forms a segment with the center because 2 points determine a segment. Those segments are all radii by definition of radius. The lengths of the radii are all the same by the definition of a circle, and all segments with the same length are congruent. Therefore, all radii of a circle are congruent. And now we're going to do 2 sample problems that make use of several of our recent theorems, definitions, and postulates. In this problem, we're given circle A, and we're given that segment LA is perpendicular to segment SC. And we're to prove that segment SL is congruent to segment CL. Well, often what we do when we're given a problem like this is we mark right on our diagram what we know based on the diagram and the given information. Well, because of the given that the two segments were perpendicular, we'll mark that symbol to show the right angles and the perpendicularity. And then we'll mark all of our radii as congruent with single tick marks. And now we're ready for our first statement. We're going to state the given that we're given circle A. And then we'll state the other given, that segment LA is perpendicular to segment SC. And then we'll note that angle LAS and angle LAC are right angles because we know that perpendicular lines form right angles. And then those two angles are congruent because all right angles are congruent. And we know that segment AS is congruent to segment AC by Theorem 19, that all radii of a circle are congruent. We shorten that theorem to simply one word, radii. But when we write radii in a proof, what we mean is that all radii of a circle are congruent. And then AL is congruent to itself. Now, it's a radius as well, so it's congruent to the other two. But for the purposes of this proof, we're going to prove two triangles congruent, and we need to write that AL is congruent to itself. And, of course, that's the reflexive property. And we'll just write REF period for short. And now you may have noticed that we've proven two pairs of sides are congruent from two triangles and the included angle, which in both triangles in this case is a right angle. So we can now state that triangle LAS is congruent to triangle LAC by the side angle side postulate. So we just write the acronym SAS. And we're finally finished. That means that SL is congruent to CL because they're corresponding parts of congruent triangles, or CPCTC for short. And we've now finished the proof of this problem. We've proved that segment SL is congruent to segment CL. And here's one more, a little bit shorter this time. What we're given is circle A and the diagram that shows several chords in circle A. And we're to prove that segment BS is congruent to segment CL. Once again, we're going to mark some things. And for the purposes of this proof, we're going to mark those two angles congruent. And of course, we can do that because they're vertical angles. And then we mark the four radii that are all congruent to each other. And now we're ready. Our first reason is to restate the given. Our strategy is to prove two triangles congruent by side angle side. So we're going to do it in order this time. So here's our first pair of sides. AS is congruent to AC because they're both radii of the same circle. And then we have the included angle, angle SAB, is congruent to angle CAL because they're vertical angles. And now the other pair of congruent sides. AB is congruent to AL because they're also radii of the same circle. So step number 2 is a pair of congruent sides. Step number 3 is the pair of included angles. And step number 4 is the other pair of congruent sides. So we have two triangles congruent by side angle side, and therefore we've proved that BS is congruent to CL by CPCTC. In this lesson, we've stated that corresponding parts of congruent triangles are congruent, which has a commonly used acronym CPCTC. This is a restatement of the definition of congruent triangles. And then we stated the definition of a circle, which many of you already knew. We also stated the definitions of radius, chord, and diameter. We mentioned that the ratio of the circumference to the diameter of all circles is the same, and that ratio is called pi. We stated the formula to find the circumference of a circle, pi times the diameter, or 2 pi r. We also stated the formula to find the area of a circle, pi r squared. And finally, we mentioned a theorem, all radii of a circle are congruent, and a very significant postulate, 2 points determine a line.